Okay, well, in dealing with files, one of those things that comes up is the fact that, yes, underneath the covers, most systems have a command line. And on Windows, that's the PowerShell. But on Linux or on Macintosh, that's a terminal. And iTerm2 is the terminal I prefer to use. Okay, it does not come with the Mac. It requires that you actually do an install to get to it. But it doesn't matter. There is also in Utilities a terminal in the Applications Utilities folder on Mac. But if you bring up a terminal, or on Ubuntu Linux, if you search in the applications and search for terminal, it will bring up a terminal. Now on Windows, you're going to search for PowerShell, but PowerShell includes most of the commands you're going to see here. And once you have Git installed, which you installed earlier in the semester, then now you have Bash. And Bash is the most common shell, although not the only one out there, or the command line interpreter. The other common one is ZSH, which has become the default in Macintoshes. In any case, all of these different shells have a common pattern, as in you type in something like echo, it's a command, and then you give it some options, okay? And when you hit return, it goes out and runs it. So until you hit return, it doesn't run it, and you get to type a line of information. So if I want to find out information about a particular command, the easiest way to do that is to do man. And give it as an option what you want to see information about, and it will tell you the documentation on that particular thing. Now, in the land of Windows, if you are just using PowerShell, there is no man command. You're going to have to use Google and search for it, and I would do something like PowerShell echo, and it will bring up a page of documentation from over the web. One of those advents of Unix that 30 years ago was amazing to me is that there was actually documentation online for the system. And you could actually do this, and if you knew where to search, you could actually manually search the documentation. You didn't have to use man to search it. But it says it writes the arguments to standard output, and it gives you this, and usually it tells you something about how it runs and where it runs, and the fact this is how this works. And if we do something more interesting, like we do man ls, we'll find out that there are, yes, ls, and then you do minus sign, and you give it an option. And look at the number of options there are. There are a slew of them. Okay, and then you list files after that. So ls has options. Now you get this different prompt down here at the bottom, and usually you have to hit space. The command that's running that shows you the documentation is a thing called more or less, one of those two. More usually is the default. And yes, at the end, it stops and you do Q to get out of the command. So if I do ls, this is how I list out a directory and what's in the directory. Okay? It lists some file names. If I do ls minus L, I'm giving it an option. There's no space between the minus and the L. It lists out the files with more information. And there's still more information you can get about the files, special options, but I will leave you with at least ls and ls minus L. And you'll notice that the last column is the file name, and it's got these things over here, permissions, who owns it, this magic number here, which is called the inode number of links. We'll talk a little bit about that. And it has a date here, which is the last time that it was accessed. It also has the size of a particular file. So you get a bunch of information about what the file is. Now, at this moment in time, it's doing a specific thing. There are two directories called dot and dot dot, and the default directory for ls is dot. So it says, okay, in the dot directory, whatever dot means, but in the dot directory, I'm going to go read the directory, find all the files, and go get information about them. So the reason why I'm doing this overview of the command line is, yes, you use VS Code, and if I do down here in the terminal window, you see it says terminal. If I do ls in the terminal window, it's actually going to, oh, wow, run those commands for us. So you are exposed immediately to a terminal window inside VS Code. That is how it runs pretty much everything. And I've put in a tiny program here. Probably looks familiar to some people. But if I run it, you notice that here is what it's actually running. It's running user local bin Python 3 in this particular case. And because I haven't configured it to use Anaconda, I think. And here is the file that it is running. Now, you'll notice it says users, Philip, Go, source, GitHub, University of Wyoming Education. Oh man, that is a long file name. But that's where we're going to start on how the file system actually works, is taking a look at things like that file name and going, here's what this means. Because, yes, to understand the command line, you've got to understand something about the file system and where the parts are. Okay, I did clear to clear what was on my little terminal screen. Clear just erases it so you don't have anything up there. And now if I do, I've changed directories so that both the terminal screen and VS Code are in the same location. So how do I determine what the location is? If I do pwd, it shows me the path that terminal is currently in. And that path determines where its dot is, basically. But let's talk about how paths work. The first thing is, you notice it starts out as the very first thing with a slash. That says start at the top of the file system, and the file system is a set of directories, and go down a directory called users, and then go down one called Philip. Philip is my home directory, so if I bring up the browser and I hit home, it'll take me to that directory. Let me give you an example here. And there is Philip, and I have a slew of things in my home directory, like documents, download, all sorts of different directories. But the home directory that's what's there. Now I could do ls, and ls has a special name for the home directory. Actually, the shell has a special name for the home directory. I can do ls and a tilde. Tilde on most keyboards is the top left key on the set of regular keys. And I do tilde, and you'll see that, yes, when I do this, I get a list of files that's in my home directory. All right, now, going back to pwd, if you want to know where you are in the directory tree, this gives you the path, the current path. Now, I can go up one level. I can do cd ... cd is how you change directories. And now if I do pwd, you'll notice that hw1 has disappeared. I can go back to that by saying cd hw1. So cd allows me to change directories. If I just do cd, it'll take me to my home directory. And you'll see I'll be in user Philip. Now this is also true on Windows if you're in Bash. And you can use these same commands to navigate around your file system. The file system is not a mystery. It is there, and as a programmer, you're going to have to get used to using it. So now if I do ls, I see the same thing I did because dot has changed from where it was to this new directory. Now, cd has a magic thing where it can do an option of minus, and that takes you back to your previous directory. Now, when I did cd minus, it actually said I'm changing directories to, oh, look, there's a tilde, my home directory /go /source github.com, University of Wyoming Education, and HW1, fall 2015 HW1. So I'm back to this directory, and I can check by doing ls, and I can say, there's my little tiny file that I created, a little tiny hello world file. So this is where I'm building my projects, is way deep down in this directory tree. Now there are plenty of directories that you might have access to on your system that you don't necessarily want to build things in. Like system directories. On Windows, you really don't want your source code built down in the Windows System 32 directory, because sooner or later that's going to bite you. Another thing that if you can avoid it, you should do is you don't want file names with spaces, because let's create a file here. And I'm going to use echo to create a file. I'm going to say this file is going to have AAA in it. And the shell has a special option where you can use a greater than symbol and give it an output file name. So we're going to put this in Bob. And now if I do an ls, you'll see I have a file Bob. And I can see the contents of that file by just typing cat and not cat AAA, cat Bob, which is the file name, and you'll see AAA. So I've created a file using echo. Remember, echo is kind of like the shell print statement, but it takes whatever you have on the command line and it prints it out. And I've combined this with an output pipe, the greater than sign, to say, here's where the output goes. Now, I can run Python the same way. Python. And I can take the output and I can say, and now I have two files, Bob and out.txt. Oh my goodness, what happens if we leave off that pipe and we just run the file? We see HW, hello world, very short hello world. But any guesses as to what's in out.txt? Well, we can say cat and we can get the contents of out.txt. Okay, so we've created two files. Now, there are more pipes and we're going to be using them, but at this point, a momentary review on what we've talked about. There's cat to see files. We've run Python from the command line. We've run ls to see what list of files we have. We've used echo, okay, and we've used pwd to find out where we are. Now, when you download a file from using your browser, chances are the default configuration is going to put it in your home directory's downloads directory. Some people change this so the download runs into documents or some other directory, but the default is downloads. And when you download the file, as in you have a link in WyoCourses and you right-click on it and you say Save As, one of those options that's there in Chrome and Firefox is what directory it's going to end up in. But the default is your ~downloads directory. Now, I probably have a slew of files in my ~downloads directory. And I've typed in ls space ~down, and I hit the tab key to get the shell to complete that so that I don't have to type in the full whole name. And yeah, I have a few files in there. But whatever set of files I have is things that I have downloaded onto this system. And when I want to run my program, now my program doesn't know about the downloads directory. Everything it does defaults to the current directory, unless I put in specifically a path to someplace else. So if I want to get this so that I can actually run my program and open a file in my current directory, then I'm going to have to move that file or copy that file from my downloads directory all the way over to this directory. So let's go through that process. Let's actually download a file and let's put it in the current directory. Okay, I have gone into the WyoCourses, the instructor system, WyoWeb, and for our class, and I have pulled up, yes, Lecture 6 with Big Book, and I am going to go, okay, now I'm not going to just click on it, I am going to, on a Macintosh, control click. On a Windows system, this would be a right click instead of a left click, and I get to this Save As option. On a Linux system, if you have a 3-button mouse, it is a right click, and I'm going to do Save Link As, and at this point, yes, here's this little dialog that I talked about that asks you what the file name is. It's giving me something. Oh, I do not like that, because does that look like bigbook.csv? It doesn't. I think that is the wrong thing. But it does say down here that it's going in the downloads directory, and I could actually navigate through the directories and get it where I want. Let's cancel that. And let's see if we can, but let's just click on this, and here's the link. It says download BigBook CSV. If we click on this, okay, and it didn't give us the dialog, but it did download it over here into BigBook CSV. And if we clicked on it, guess what? It would bring it up in some application that I don't want it to. And we're going to talk about how it chooses those applications here in a minute. But let's do ls downloads again. And when we do that, you'll notice before this wasn't there, but there in my downloads directory is the file that I'm looking for. Now, I can move that file to my current directory. Move is a rename and allows you to move things in your entire file system, or I can copy it. Now, I don't particularly want to leave it in my downloads directory, so I'm going to move it. And over here, if I just say move mv, and I put in squiggle downloads, and I did DOWN tab to complete it, and I put in big tab to complete it again. The Macintosh asked me for permission because of security reasons. A Windows system probably won't ask you that question. And I put in dot. Remember, dot is the current directory. Now suddenly I'm going to move that file from where it was to my current directory where my program is. And look, over here in my list of files, Big Book CSV is now there. Okay, I can also go in here and do ls, and I can get to bigbook.csv. So knowing that dot is the current directory suddenly becomes important, and I've added to our set of commands that we're familiar with now, mv. I could have also said copy cp if I just wanted to copy the file and leave a copy of it in the downloads directory. But mv move actually takes it from there and puts it in this new directory. So this is how you rename files to where you need to have them for doing your homework. Now, I've gone through in the lecture notes this time and I've put together a list of the commands that are the most common commands in a Unix environment with at least a one-line description of what they are. And there are more commands. I have some 3,000 on my Macintosh. About 1,000 is pretty normal on a bare system when it's installed. But I've picked out the ones that you are most likely to need. And it's worth reading through that list and maybe even keeping a printout of that list, because if you become confused about a command, you can always do man and get the information on where that command is, what it does, and how it works. But we're going to go through some of the things that are just above the level of the commands and take a look at how they work. And this is one of those things that Unix developed 30 or 40 years ago, 50 years ago, in 1969, 1970 time frame. So 50 years ago, that has proved to be one of the most useful things and is the best example of software reuse in existence. And that's Unix pipes. You'll notice that when I said ls, it printed out the directory for that system. You'll notice when I said ls that it printed out the current directory. So it did ls for basically dot. And there are options I can get. ls-l dot, and it prints out the current directory. Or I could leave off the dot because the dot's the default. Now, say that I have a directory that has a lot of things in it. There is a command called grep that will allow me to search through text for a pattern. Now, I'd like to be able to take what I have from ls and actually search it. So I can send the output of ls to another command. And I use a vertical bar. On my keyboard, it's way over on the right, right above the backslash. I use a vertical bar and I say grep for G's. I can use a bigger pattern, but G's will find something here. Okay. Now, when I did this, I found that there was 2 different G's in the output of ls. And one of them was kind of a surprise to me because I knew there was a G in Big Book right there, but there's also a G in August right there. So you can tie these commands together in an effective fashion, where you run one command, you take the output from it, and send it on to the input of another command. Now, one of those things that happens to me commonly on Windows is Chrome locks up and won't do anything. And I just don't find Windows to be the most reliable system in the world. I use it. There's some things that it works great for. My video recording stuff, a lot of it is done on Windows. It has lots of capabilities and there are some nice things about it. But I also find it unreliable. So sometimes in Windows, I need to do some interesting things. Now, PS lists the processes that you've run. And this set of processes, okay, has over here the process ID, this very first column in this case, and you can give options to it. Now, if you have multiple windows open, PS by default just lists the set of processes that are tied to your window, okay, your terminal, but you can list all of them. You can do PS minus EF, and most systems it's EF. There are some Unix operating systems that this will be PS minus AX, okay? Because there are different versions of Unix out there, but PS minus EF, and you get something that scrolls off the screen and is too big to look at. But guess what? If I want to find a particular command and I want to see just what is happening with that command, I can look for that command. And I happen to know, since this happens to me frequently, that if I do ps minus ef and I send that through a pipe and I do grep for Chrome, I will get all the instances of the Chrome browser. And suddenly I can say, okay, I really, really like the Chrome browser, but it is stuck at the moment. And if I do ps minus ef and pipe for grep for Google, it gives me that. If I do an option on grep, okay, that's the one I'm looking for, where it lists all the different parts of the Chrome browser. And what I did is I told grep minus I, which is case insensitive, to look for Google. And guess what? There are all the Google Chrome things on my system running, and there's a bunch of them. And one of them is stuck. It is no longer responding to mouse inputs. You can't switch the tabs on that screen at this very moment in time. Now, this is nice, but what I'm really interested in this case is this second column. If I just do ps minus ef and I pipe it to more, you'll see that the second column in this output is the PID. And the process ID is what I'll use to kill it. I want to do Q here to exit the man command and go back up to my ps to grep. Now, there's a text processing command, and I know exactly one option in it. It's awk. It's a full programming language. I actually do know some more. But the only one that I use on a regular basis is to take this and pick out a column. And the nice thing about this is when I do ps minus ef through grep, I can then pick out a column. And the column I want is column 2. So I do awk, and it does its column names with a $sign in the column that you want to pick out. And suddenly, yes, I have a list of all the Google Chrome process IDs. And I've done this with just a short command. Now, as soon as I have this list, I can go kill them. Okay, and here comes another command. So we talked about ps, a little bit about grep, a little bit about our text processing language, awk. And at this point, I want to kill them. Now, you can take the output of one command and you can put it back on the input of another. So if I say echo A, and I want this to happen, I do $paren ls. Okay. Ah, look at that. It says A big book and it lists all the things. Now remember, ls had those things, and I've taken the output of ls and I've put it on the command line of another command. So if I go back to my kill or my command here and I do kill, I think you can see in the background there that the browser disappeared. But guess what? I just killed all of those processes in this list with a command where I did a search. I said, give me the list of all the processes in the system. Give me the list of all the ones that are matched with a case-insensitive Google. Cut that list down to just a single column using column 2, because I wanted the second column out of that. And then take the output of that and put it back on the command line for this program kill. Now what kill does is it terminates other processes on the system. So it's a kind of a scary thing. You wonder, okay, if I terminate this, what are going to be the bad effects? But generally speaking, with Google Chrome, it will come back and just reopen stuff. And it says, oh, I'm really kind of goofed up here. But yes, it will give me the option of reopening things if I go into the history and I go pick up the history of recently closed. I can reopen all of those tabs. So yes, Chrome is pretty friendly about that. Some other programs, if you kill them, if they are stuck, you are going to lose stuff. Okay, as in it will terminate, but it will not have anything that you didn't automatically save. But the combination of being able to take a program and do some things and this chain of events and turn that back into stuff that you run is tremendously powerful and immediately powerful. So when we look at the different kinds of commands, in today's lecture. I'm not in the right directory. Let's do cd2. And we go and look at this list. Okay. I'm kind of working down through these things and showing you some of the things. I did a bunch of the different file navigation commands like ls, cp, rm, and a file name removes it if you want to delete a file. We're coming up on a homework exercise where I have cut down the amount of data that is there from a complete human genome, which would be very big, to I think just 100 megabytes. But probably when you get done with this homework exercise, you want to delete that file. And the way to delete it is do rm space and the file name, and that will get rid of the file. So when you do ls, it isn't there anymore. And it didn't just go over to your waste bin or your trash can and have you delete it. Rm is commitment. It is gone right then and there. We haven't talked about some of these other things like changing ownership, but this gives you a starting set of commands that you can work with. And the really important ones, like how do I get a file from one location to another location? How do I move that file? Now, in Windows, you probably see files and they don't have an extension. And we're going to get back to that. Let's go back to this directory. Again, we're back here in where I have my little sample directory. And you'll notice that I have Bob and it doesn't have any extension at all. That's no .txt, no .csv. And out.txt. That last piece after the last dot is called the file extension. And file extensions are used by default to be able to determine what program to run when you double-click on the file name. In the Explorer or on a Windows system in the Finder, okay? The Finder is this little goofy guy, okay? Or on a Linux system when you run Nautilus, the desktop file explorer. And if you double click on a file, that extension gets looked up and a program gets run. That's all the extension does. Now, Windows, unkindly for developers, has chosen to not show the extensions. And as a developer, this drives me absolutely bonkers, because suppose I've got an out.txt, an out.csv, and out.xyz, and I need to know the difference between these, and it shows me out, out, out. Okay, and I'm going, what is going on here? If you go into the options for the Windows Explorer, the Desktop Explorer, there is an option in there to turn on showing file extensions. And when I get a Windows system, one of the first things I do is I bring up the Explorer, I go to the options, and I turn that on so it shows the whole file name. And I can't tell you where the option is, but I know it is there. And if you Google Windows Explorer show file extensions, you will get to a page that will walk you through setting that for your version of Windows. And I highly recommend that if you're using Windows, turn that on immediately so that you can see what your files are. Now, file extensions are just the default program for running a file. You can change what that default program is. And consequently, some people aggressively go when you install a piece of software and change this for you because they just know better than you how you want to use your files. VS Code is one of those things. It changed all my .svgs to show up in VS Code. Very irritating as far as I'm concerned. And I do use other tools like Adobe Premiere that thinks that suddenly all my .mp4s should show up in Premiere if I double click on them. Well, guess what? I occasionally watch a movie and I want it to show up in VLC. So, yes, the default is just the default, and I may want to change it to something else, or I may want to take it away from a program. And I don't want a single program to be in control of everything I do. As a computer user, most people are one program specialists. And I have seen, yes, over and over and over in the years, lots of cases where people build tables of numbers with calculations in them, and these tables got complex mathematical calculations like calculating a mortgage and the future value of a mortgage, or calculating lease payments. And these are like one-line calculations in Excel, But they are really, really ugly when you use the calculator inside um, Word or Pages to produce this, because the person doesn't know Excel. All they know is their document editor. And consequently, if the only tool they have in their toolbox is a hammer, by golly, everything looks like a nail and they're going to hit it. You're a programmer. You do not have that luxury. That is beyond your scope. Okay? You have to use lots of different tools, and having a single default for, yes, if I double click on this, this is how it's always run, does you no good whatsoever. Okay? A file may be input to one program and output from another. I just showed you that with PS-EF. And certainly there are more than one way that you want to look at a file. Just because it's .py doesn't mean if you click on it that you want to run it. It may mean that you want to edit the file. You may want to change the file. So you have lots of programs. And on a daily basis, I use maybe 19 different pieces of software regularly. Okay? So in a particular project, if I'm building a web page, I'm going to be using Photoshop for images, maybe GIMP for images as well. I'm going to be doing some stuff where I'm interacting with those files to send them and receive them from servers. I'm going to be using a browser for debugging. I'm going to be using clients like wget and curl that aren't browsers but are web clients. I'm going to be using different tools for different things. I'm going to be using an editor when I've got a JavaScript file. And then I'm going to be using a previewer or a dedicated style sheet tool like Canary for dedicated style sheet work when I'm using a CSS file so that I can manipulate stuff. So you use a lot of tools, and having a single default for, by golly, it's a .py and I double click on it, gets me nowhere. It just interferes with my life. So yes, I do double click on files. But if I bring up the File Explorer in this current directory, and on a Macintosh you can just say open dot, on Windows you're going to have to navigate to it, but if I go out here and I just double click on this file, I get, yes, the Macintosh default text editor. Or is it? Yes, it's the Macintosh default text editor. This does nothing for me. Okay? I just want to exit that and get out of it. I don't want to use it. Maybe you will be satisfied with an editor with no commands in it, but basically it is a dumbed down editor. Now, if I bring up the context menu on this, and on a Mac I did control click, I can do open with, and I'm usually going to use this thing called VI or Vim to edit files. There are other text editors, but you'll notice that in this list is my Visual Studio Code app, Xcode, which is the development environment for Macintoshes if you're doing a desktop or an application. Xcode if you're doing some sort of a desktop application or you're doing an application for an iPhone or iPad. It has to be there, although I have it installed when I build applications these days for that. I use a different tool called Flutter, but you still have to have Xcode installed because that's where all the compilers are. And you'll notice in a bunch of other applications in here that you go, why are these there? But they've used some sort of a heuristic to say, by golly, if you have a file like this that's a text file, these are things that could probably open it. And you'll get unusual results from some of these if you open them with, say, Adobe Illustrator and a text file. That probably will not do something you want. Now, here's the reality of all of this. Yeah, I'm going to use VI. VI is not an editor that is easy to use. But it's kind of like this. When you go in and you use Word, you can just kind of like bring it up and you type some stuff and kind of you get some results, but you don't have to have a lot of expertise to use Word. It's kind of self-documenting. VI is not like that, and the command line is not like that. These are things that you actually have to learn a bunch of commands to use. But they are really useful and really powerful once you've learned them. Now, this is kind of like learning a musical instrument. You can't learn VI in a day. If you go look for VI tutor or tutorial, I will put a link in the comments or in the notes for this lecture. There are sites that you can go to, very good sites that will walk you through basic VI commands. And you even have to learn the basic commands, like how do I save a file? There is no menu. But I will also point out to you that in surveys that they have done, really big surveys, they find that people that know how to use VI make more money in the computer field by a substantial amount, like $14,000 a year. So it's worth learning, but you are not going to learn it in an afternoon. There are at least 3,000 commands in VI alone. And they are esoteric things like :WQ. Now, VI is different than most things that you've used, as in it is a modal editor, as in when you want to insert something, you type I to insert, and when you're done inserting, you type escape to get out of insert mode. But VI is the only editor out there that is designed to be a touch typist editor. And I don't understand people that learn to program and don't learn how to touch type. If I'm stepping on your toes and you haven't learned how to touch type, I apologize right now. But let's be serious about this. I have never seen a concert pianist hunt and peck for the keys on the piano. Okay? Yes, it does take effort to learn, and it's a musical instrument, but once you learn it and get good at it, it increases your productivity. And I am still, 30 years later, learning commands and new things in VI. So there is a lot to it. Now, at the command line is the same sort of thing. If we go back here, and I just do, some command like find, there are options I don't even use on find. But if I want to find a file, I have lost a file somewhere in the file system, and I know it's somewhere in my home directory, I can say find, and -name, and I can look for big book.csv, and I can say that I want all the errors that come, because it's going to find files that it can't even read in directories, and I want to take all of those errors, there's a special pipe called to, and send those off to dev null. In a Windows system, if you're in the bash shell, I don't know if it understands dev null, there is a null device called NUL : that you could pipe to, but this gets rid of the errors. So I'm going to take the output of this and I'm going to say, let's get rid of it and just find where it finds in the file system this file. And I guess you guys are probably noticing that it's taking a little while, but it's finding every path where this file exists, not just the current path. We're in that very first one, HW1, but it also found it in Lecture 6 and Lecture 6 data. So here's where you say, okay, I've lost this file and I need to go find it again. Where is it? And you go, okay, we're just going to run this command line thing. And find says find from the directory tilde, which is our home directory, in my case, /users/Philip. On a Windows system, it's going to be /users and your username. On a Linux system, it's /home and your username. But go to that directory, start there, and look for the thing with the name big-book.csv and tell me where it is out there. Okay? This is how you recover files that you've lost. Now, there is a find, a little Sherlock find in Macintosh that's a little up at the top, a little thing. But when it finds it, it doesn't tell you the path. It tells you, here it is, and you can double-click on it. And that's generally not going to be really useful. So I rarely use it when I'm doing development. It is very useful when I have lost a movie that I want to watch or some video and I know the title of it. It's really good for things like that. It's not really good for development. For development, if I've lost a file, I'm generally going to be using find. So here's this other thing that is a musical instrument. It's the command line. It has lots and lots of commands. You can add your own commands to the command line. And I do that regularly. I have all sorts of scripts that I write that I add to it so that, one, if I have some complicated command I use frequently, I can reuse it and make it a little simpler for me, or I can put it in a location where I can find it and go read the script and find out how the command works. So it's kind of a mix between usage and documentation. Or here's a whole bunch of commands, literally thousands of them that you can use that people have developed over time and you get to reuse. Now, there's one more pipe that I haven't talked about. We've talked about the greater than, the to greater than that sends errors off to Never Never Land, the bit bucket at the end of the universe. And we've looked at the vertical bar that sends it from one command to another. But there is another one that allows me to take input from one command or send input to a command. Let's put it that way. If I have a program that just reads from the terminal, and I would like to be able to take that command and take it and send it a file, I can say, I want it to read out.txt. Now, I know that you could just put cat out.txt, but I have actually put in, yes, a less than symbol there to say pipe this to cat. And in this case, it's not going to know the file name, but the shell is providing it with, there is my contents of my tiny little file. But this set of pipes is really useful and common. And that is also in the lecture notes for today, and you should know what those different pipes are and how to use them. If nothing else, your Python programs for this homework, when you're going to run stuff, not so much this next homework, but the homework after this, you need to send me the output from running your program. So what are you going to do? You're going to go into the command line, and this could be over here on the little terminal inside VS Studio, or you could bring up a separate terminal, and you're going to say what? Python. Hopefully you're getting the correct Python. And you're going to take your program, and you're going to pipe it to some output. And now you have a file. When you want to be able to get to this file and upload it, you're going to need to get something like the Explorer, and you're going to need to know what path you're in. So you can go, oh, I'm way down in this path. I need the Explorer so that I can take the file and I can drag it in, or I can use the browser and browse to that local directory to open the file and upload the file. So these are critical pieces for you understanding where you are and how these things work. Now, I can't teach you all about the command line in one lecture. It is impossible. But this is the tip of the iceberg, a little flavor of the command line. And there is plenty more to learn, and you can do all sorts of stuff with the command line. I commonly use a programming language called R for statistical stuff. And there are languages that I use quite often for text processing. Awk is one of them. Perl is another. Because they fit in well with the command line. And they allow me to do big things quickly without having to do them over and over by hand. And that's what programming is tackling huge problems and reducing them to, oh, you mean you did this in one line. And one last little shout out for VI or Vim. The university and the agriculture department actually uses VI, and they teach it for their data analysis class, their computers in agriculture class. And the reason why is because VI is on everything, and it works well even on huge files. When I get a gigantic file that is way bigger than the memory of my entire computer, I can just go VI and edit the file. And yeah, it might be a little bit slower, but if I want to search in that file for a particular thing, or I want to see the structure of that file, chances are, if it's a text file, I can use VI to edit it, and I can go searching through it. It doesn't matter how big it is. If I have a log file that is 20 times the size of the memory of the computer, a gigantic log file, and I want to get down to, line 5,231,000, I can do that in VI. And yes, I type in that number and tell it to go to that line with a capital G, and it's going to take a few seconds, but it can yet edit that file. I can look through it, I can poke through it, and I can search it. I can do that on my router, where it doesn't have very much memory, and I can do that on my light bulb. There's a VI editor on my light bulb. So knowing this editor is useful. I recommend it. It's not required for this class. We have a nice editor that has a few commands in it that you can use in Visual Studio. And it actually has a VI emulator if you want to turn it on and use it in there. It emulates the GUI commands of VI, which isn't very much. It's not a good emulator of VI, but it does emulate some of VI, and if you're used to VI commands, it gives you, a so-so editor of it. But yes, VI is super powerful. There are lots and lots of commands to learn, and sometimes you're going to type in something and you're going to be shocked at what you get. Now remember, most of you are using bash or ZSH, but remember you can do man bash. And oh my goodness, the born again shell, and you're going through documentation. Oh my goodness, there's a lot of stuff involved in a shell. Actually, 80 pages of information on the shell. So some of these documents are long. Probably the most painful part of installing software on any system is one particular thing that the shell uses, and that's the path. Notice I put a $sign and I put capital path here. This is what my path looks like on this system. There are variables in the shell just like in Python, but it says that this is where it looks for things in order. And these are separated by a colon or a semicolon depending on what system you're on. On Windows, the path is built into the operating system as opposed to the shell, and you have to go into the configuration for the system and find it. But if you Google for setting path, and I think some of you, I sent out a link for this once already in this class, it works in a different way. But if you're in the bash shell after installing Git on Windows, you can do echo path just like this, and you can set the path for the shell. And it will work just like a Unix system. But each one of these things, it searches in order. So it says, this is the first place it's going to look for commands. And then this is the second place it's going to look for commands. And then, interestingly, I have a third place, dot. My third place is the current directory. So if I build something, I can search for it in the directory that I'm in. So when I'm doing software development, I don't have to say, go to this big long path to run my program. I've built something, I've compiled it. I can just say, here's my program I want to run, and I just run it in that current directory. Now, most programs in the Unix world have a configuration file in your home directory. And bash or ZSH, I'm running ZSH here, so I'm going to give you a ZSH example, it will be the name of the command .rc with a dot in front. Now, what is the deal with these dots? But if we go and look inside my ZSH-rc file, you'll see that I have set up some stuff in there that makes it convenient for me, including, yes, at some point here, I set the path. I set some other stuff. This piece of stuff right here is the setup for running Anaconda Python. And you need that in your .bashrc or your .zshrc so you can set it up. And in the middle of that, it goes and it says, oh, I'm going to set the path to some additional things. So you get an opportunity to set these important things and set up an environment and determine how it's set with these initialization files. And just like .zshrc, there's a .bashrc, there is a .vimrc. Most commands in the Unix world allow you to have this configuration file at the beginning, but you have to read the man page to find out what it is and how to set it up. So that is what I have in terms of my setup for this, is basically the path and some other things. And these allow me to be able to then run Python. And when I run it, I notice that the first thing at the beginning of running Python is, yes, it has the correct version, and it seems to be Anaconda Python. So that when I run Python, I get into the correct version of Python for what I'm working. So the question then is, if this thing is using user bin Python 3, is that what I want? Probably not. If I come down here, I really want to be able to set the correct Python. I clicked on the wrong thing here. But you'll notice that this is back to the version 2.67 or 2.716 of Python, which is not what I want in this directory. I really want user bin Python 3. I want opt anaconda. I want this one down here. And as soon as I did that, I got another file over here, which is a configuration file. But now when I go and run my Python program, I'm actually running the correct Python here to run the program. And that isn't so important right now, except that there are things in 2.7 of Python that don't work when you run stuff. Now, if I got this set correctly, this would be automatic, but it doesn't seem to be that case so far for me. I'm still having to reset it every time I go in and create a new directory with code in it. But once I've set it in that directory, it persists, and now I'm getting, yes, Anaconda Python, which is the one that I want to use for this class. So I think that's kind of an overview of the file system and how we use it. If you have to refer to something in the current directory, as in there are multiple locations where that file exists, you can always do // which says the current directory / is the separator in paths and then the file name. But generally speaking, if you get the right defaults, it defaults to the current directory. And with that, let's move on to something else, but this should give you enough of an overview to be able to use the command line with some degree of frustration, I suppose. It's not a complete command line thing, but at least to get around and the very basics in using a command line, which is part of your VS Code environment.